Now I'll maximize. All right, so we're going to simplify a to the 6th times b to the 8th divided by a to the 10th, b to the 3rd. Notice this whole term in my denominator is still a monomial. Still a monomial. Remember, terms are separated by pluses and minuses. So right now we have a monomial. Okay? So what I'm going to do, and you don't have to do this on every single problem, but this is the way that we approach this. Okay? What we can do is we can think of this as like two little mini problems. First, it's going to be a to the 6th divided by a to the 10th. And then the second one is going to be b to the 8th divided by b to the 3rd. And then you just multiply the answer together. Now, my thing is this, because we're going to start seeing stuff like this. For the first part, a to the 6th over a to the 10th. I know the bases are the same, so I'm going to subtract the exponents. But what I'm going to do is this. I'm going to start writing boxes while I'm learning this. And the reason why I'm putting boxes there is because I know the numerator goes here and the denominator exponent goes there. So it's going to be 6 minus 10, which is a to the negative 4. I'm going to leave it like that for now. We're going to leave it like this for now, okay? For the letter B, I put the boxes first and then I make my substitution. And if you want, you don't have to use boxes. You can use parentheses. That's fine with me. But this is going to be b to the 5th. Okay? So if we look at the two results that we got, a to the negative 4 and b to the 5th, we know we have to multiply them together. It's just we don't like negative exponents. So that a to the negative 4, I'm going to rewrite is 1 over a to the 4th times b to the 5th. And I can put that as 1. So this is just going to equal b to the 5th over a to the 4th. Does that make sense, everyone? So the only thing I did here is I really drawn this problem out. I separated things because I wanted you to see how this works. But eventually, hopefully you can get to the point where you don't have to worry about that anymore. Okay? Are there any questions before we move on? All right. So let's do another one very, very similar to this. X to the 9th times y to the 3rd, z to the 4th, all over x to the, let's say, 7th, y to the 8th, and we'll just write a z. All right, now, for me, I take a step back and I look and I go, okay, I have x, y, and z in the numerator. The question becomes, do I have x, y, and z in the denominator? If the answer is yes, then you know bases are the same, subtract the exponents. So I'm going to write x, and then I'm going to look at my exponents. 9 minus 7 is 2. Now I'm going to look at the letter y. 3 minus 8 is going to be negative 5. And then z is going to be 4 minus 1, which is a 3. Are we all on the same page so far? Now, I want to write my answer with positive exponents only, so that y to the 5th is going to have to go down in the denominator. Because remember, that negative exponent rule, I'm going to scroll back up to the negative exponent rule real quick. Here it is right here at the very top of your screen. Remember, this is the reciprocal rule, meaning if the negative exponent is in the numerator and you flip it, it'll be in the denominator, but now it's positive. So that's exactly what I'm going to do with this right here. I'm going to write x to the 2nd, z to the 3rd, all over y to the 5th. In other words, I'm going to put it in the denominator. Does that make sense, everyone? Now, the next example really drives home the point of we got to really understand what's happening here. All right? So I want you to do this example because I want to see if you could just get it. That's it. Let me change this exponent. Let's make it a 6. All right, so go ahead and try that one. All right, who got an answer? Or do you just want me to give you my answer and then you can compare? Hi, Kitty. Austin, what's the name of your cat?
His name's Buddy.
Hi, Buddy. Yeah, you just can't let an animal on the screen without me saying what's the name. So hi, Buddy. I got a cat just like you. His name's Galileo. And Galileo would know the answer to this question. The answer to this is x to the 11th. So how in the world did I get x to the 11th? Well, what rule do I need to use here? What do you think? What rule do I need?
Negative exponent rule.
The negative exponent rule. So it's going to be x, and if I were to draw these boxes first and then make my substitutions, notice I have a double negative right there. And when we have a double negative, what do we convert that into?
A plus sign.
A plus sign. Very good. So this is going to be x to the 5 plus 6, which is x to the 11th power. And that's where you need to be careful. You got to be careful on that. So if it were me, if you want to put parentheses first and then make your substitutions, hey, I am 100% cool with that. I encourage that because you don't want to miss something like that. That's a really easy problem to like overlook. So be careful with this, okay?
Yeah, that was tricky for me.
Oh yeah, I know. It everybody misses that. Because you see the minus sign and you're thinking, "Oh, it's already there. I don't have to do anything." And that's not the case. All right? So it's the numerator exponent minus the denominator exponent. So now I'm just going to throw you into the deep end. Sorry for this, but you'll be fine. Here you go. Oh, I lost place. There it is. So go ahead and try that problem. All right, who got an answer? Positive exponents only.
I think I do.
All right. Hold on one second. Let me write this down. Now, I don't know if this is correct, so just give it to us and then we're going to do it.
Negative 3 over x
Where's the y to the 5th at? Is it upstairs or downstairs?
Downstairs.
Okay. All right, so we got an answer. Anybody else get this? Megan H, you got it as well? All right. Well, let's go through and do this, okay? So I want to do the easy part first. The easy part is right here. It's these two. Because the bases match, so we're going to go ahead and subtract exponents. X to the 4th divided by x to the 6th is x to the 4 minus 6, which is x to the negative 2. That goes in my denominator. Next one is going to be y to the 10th. Y to the 10th minus to the, or I'm sorry, y to the 10th divided by y to the 15th is going to be y to the 10 minus 15, which is y to the negative 5. So that is also going to go down here. I got to be honest with you. The hard part is the fraction. It's the numbers. 54 over negative 18. First, you got a positive 54, a negative 18. Answer's negative. So I'll put a negative out front. Second, we need to reduce 54 over 18. Now, if you can see it, great. But if you can't, I want to show you something. Now, I just got done teaching this last week. So, what is it? 54, 18, okay. So the technique I'm about to show you is called prime factorization. I'm going to break down 54 into nothing but the multiplication of prime numbers, and you're going to see why. So two numbers that multiply to give you 54 is 9 and 6. 9 is 3 and 3. 6 is 2 and 3. Notice all the numbers down here that I circled are prime numbers. If a number's not prime, it's called composite, meaning it can be broken down even further. So I'm going to do the same thing with 18. 18, 2 and 9, and then 9 is 3 and 3. Now, if you're asking yourself, well, why is he doing this? Here's why. I'm going to rewrite 54 as 2 times 3 times 3 times 3 in my numerator, and then 18 is going to be 2 times 3 times 3 in my denominator. Now, we all know 2 over 2 equals what number specifically?
1.
Good. So I could scratch these out and replace it with a 1. And the same thing is going to happen for the 3 over 3 and then the other 3 over 3. So when everything is all said and done, in the numerator, I'm left over with 1 times 3 or just 3. And in my denominator, I'm left over with a 1. And that is how Wesley got 1. Or I'm sorry, that's how Wesley got 3. So I love your answer of negative 3 over x squared times y to the 5th. Does that make sense, everyone? All right. Every single fraction that you ever see, it can be done the same exact way that I just did with reducing like that. Every single one. All right. Sometimes you might be able just to see what it is. Other times, just break it down. I don't know about you, but I'd rather take a little bit more time and know I got the answer correct. Or B, I'd rather be absolutely positive that I know I no longer have to simplify that fraction. All right? Let's do another one. Now, I know this one looks crazy. There's a lot of things going on here. We have all the tools we need to simplify this, though. Let's do this one together. First, 65 over 42, they're numbers. That's going to take me a lot of time to do that. I'll wait till the end. Second, we have A, we have a B, we have a C. So we know we're going to apply quotient rules there. Notice that d to the 4th is in the denominator and there's no other d's. So far, here's what we know. Our answer is going to have d to the fourth in the denominator. It doesn't change. How are we looking so far, everyone? All right. From here, let's do A, then B, then C. So we got a to the 10th minus 7. So 10 minus 7 is a to the 3rd. That's positive. I'm going to put it up there. Now, if you're asking yourself, well, how did I know to put it upstairs? Remember, this is a to the 3rd over 1. Since this is in the numerator, when you create the fraction, it stays in the numerator in your answer. All right? Now we're going to do b. So it's going to be b to the 8 minus 7, or I'm sorry, 8 minus 6. So that's going to be b to the 2nd. Now we're going to do c. So that's going to be c to the 5 minus 8, which is c to the negative 3. And when I rewrite that as a positive exponent, it will go in the denominator. How are we looking so far, everyone? All right. Now here comes, like I said, here comes the fun part. 65 is 5 times 13. 42 is going to be 6 times 7. And then I can break down that 6 into 2 times 3. Remember, I'm picking prime numbers. Okay, are there any questions so far? Yes or no? All right, now, Amy, help me out. When we just look at the numbers, 5 times 13 and then 2 times 3 times 7, do any of them reduce? No. So let me ask you the question then. Does 65 over 42 reduce?
No.
Exactly. So our answer is going to be 65 over 42. And then in the numerator, it's going to be 65, a to the 3rd, b to the 2nd, over 42, c to the 3rd, d to the 4th. So let me ask this question while we're writing that down. Let me ask this question. How many of us, and you don't have to answer me, but I just want you to think about this and be honest with yourself. How many of us were looking at that 65 over 42 and said, that has to reduce? And then maybe you start trying some numbers and it didn't work and you're like, all right, fine, I'm not even going to worry about it. I'll take the hit on that one. You don't have to tell me. What I'm saying here is this. Take the extra 30 seconds, write out the prime factorization of each, and if you see numbers that are the same in the numerator and denominator, scratch them out. If there are no numbers that are the same, then you know 65 over 42 is already completely reduced. There's nothing you can do with that. Sometimes, when we're reducing fractions, we either A, don't even know if we're done reducing, or B, the numbers are so large that you're like, I'm not even going to try it. Now you've got a foolproof method. You will see when it's done. Good? All right. So let's move into section 6.6. Now this is where things are going to change up a little bit here. This is definitely what I personally think one of the more difficult topics we're going to do. Okay? It's definitely going to be more difficult than what you're used to, all right? So this is called, I forget what it's called. Oh, dividing. So divide polynomials. All right? So this is very, very general. Now, we will learn in this class 2 different situations. If you take me for pre-calculus, we're going to add another situation on, all right? So for us right now, there are 2 types. Type 1, and I'm going to put a smiley face next to this one because this is my favorite. The first case or the first scenario we may run into is dividing by a monomial. We like that one. Leah, that one's really easy for us. It is. You'll see why. The second case, however, is dividing by anything larger than a monomial. Examples would be binomial, trinomial, etc. This one is the more difficult one. Okay? But here's what's nice. You already know how to do both cases. You were already taught how to do both of these. It's just now we're going to have to put everything together. So the first thing that I want to do is I want us to do case one. We're going to do a couple examples of case one, and we're just going to keep it simple. Okay? So here's our first example. I'm going to keep it really simple. How about that? I'm going to keep this really simple. 1 plus 3 in the numerator over 6. Now, a long time ago, you were taught this. You were taught that if you have two fractions that you're adding and they have a common denominator, you are allowed to rewrite the denominator and then add the numerators. So you would get 4 over 6, and then you would have to reduce this. And it turned out the answer was 2/3. Okay? Today, we're going to look at the problem above, which is 1 plus 3 in the numerator divided by 6. Well, since this is a monomial, what you're allowed to do is break up. In other words, what we can do here is we can rewrite 1 plus 3 in the numerator over 6 as 1 6 plus, 1 6 plus 3/6, and then we would go ahead and do our math. All of us in this room, we've all seen this problem before, especially previously from walking into MAT090. We've all seen this. We're going to apply the same technique to a more complicated problem like this. Now, like I said, this problem looks more complicated, but if you were in an airplane and you were looking down onto this problem, hopefully you would see that we have two things in a numerator that's being subtracted divided by a monomial. And if you have a monomial in the denominator, just like the previous problem, what we're going to do is we're just going to break this up. So does everybody see what I did there? Does everybody see what I did? Okay. So now, if you really, really think about this, everybody just watch the screen real fast because I'm going to do something real quick. If you really think about this, you have two problems. You have this one right here, 32 a to the second b divided by negative 8 ab. And then you have that problem right there, which is negative 16ab squared divided by negative 8ab. So what we can do is we can simplify each one of these and then just write the answer. Now, I see something that's bothering me, and it's right here. I have a double negative back to back. So I'm going to rewrite that as a positive first. Now, if you want to, just watch. I'm going to do the first term. 32 divided by -8 is -4. A to the second divided by a to the first is a to the first. And b over b is 1. So this whole first term simplifies into -4a. Then you have a plus sign. So you drop it down. 16 divided by 8 is 2. A over a is 1. And b to the second divided by b to the first is b to the first. And there's your answer. So the key to dividing by a monomial is just to break it apart and simplify each term that you have. Do it one at a time. There's no rush for this. Does that make sense, everyone? All right. Did I hit record earlier, did I? Oh, I did. Excellent. I don't want to get yelled at. It's Friday. I just want it to be Fun Float Friday. All right. Let's try another one like this. So we're going to divide 36x to the third, y to the second, plus 27x to the second, y to the second, minus 9x to the second, y to the third. All that's going to be divided by 9x squared times y. Now, I know this looks cumbersome, right, Megan H? How would you approach this problem, though, Sydney? What would you do? Now, remember, you're muted. Say it again?
I'd break it up.
I'd break it up as well. So I'm going to write 36x to the third, y to the second, over 9x squared y. Now, if you look in between the 36x cubed y to the second and the 27x to the second y to the second, if you look in between those two terms, there's a plus sign. So put a plus sign, okay? Now that middle term is going to be 27 x to the second, y to the second, over 9x to the second times y. Now the last sign is a minus sign, so put a minus sign. And then we have 9x to the second, y to the third, all over 9x to the second, y. There we go. Are there any questions so far? Because I don't want to move too fast. I want to make sure we're working on a nice pace. All right. Genga, are you with us? Uh-oh. Boy, that's the worst when you get called on and you're not there. It hurts it breaks my heart. This guy. Broken. So now I call on someone else. How about Dylan? Dylan, are those your hats hanging up on the back of your wall?
Yeah.
So
You know what the funniest part is?
I only see 12 of them.
I got like 4 more on my dresser.
And what's the funniest part?
I only wear one of them.
Oh, I don't even wear a hat. How about that?
Yeah.
I only wear a hood, and that's only in the wintertime.
I like wearing hoods too.
Hoodies are great. Why don't you help me out with this one, Dylan? So you and I, we're just going to work on the first term.
Okay.
36 divided by 9. Do you know what that is? Agreed. X to the third divided by x to the second. What is that?
X.
And y to the second divided by y. Say it again. I didn't hear you.
Y.
Perfect. Thank you. Now you got a plus sign, so let's drop it down. Brianna, you with us?
Yes.
Perfect. 27 divided by 9. Do you know what that is?
Agree.
Good. X to the second divided by x to the second. What is that?
X to the second.
Yep, x to the second over x to the second is x to the 2 minus 2, which is x to the 0. And what is x to the 0 power?
0.
Oh, be careful. You can phone a friend in class. You could pick on anybody you want. Dylan raised his hand. But you got to ask him nicely. Dylan, could you help me out? You got to say it, not me.
Dylan, could you help me?
1.
The answer is 1. Very good. So remember, anything raised to the 0 power is 1, except for 0 to the 0. So if you wanted to, you can write times 1, which is fine with me. But Brianna, we're not done yet. Y to the second divided by y to the first is? So if you have to write it out, I'll write it out, So y to the second divided by y to the first is going to be y to the 2 minus 1. So what does that equal?
Y to the first.
Beautiful. Love it. Thank you. Next. Drop down the minus sign. Let me erase this work on the side. Mara, how are you doing? Oh, I'm going to have to start writing down names now. Not good. All right, Dawn, you're up.
Okay.
All right, here we go. What's 9 divided by 9?
1.
Love it.
1x.
Oh, slow down.
Oh, okay.
9 divided by 9 is 1.
Sorry.
That's okay. X to the second divided by x to the second is what?
X.
Be careful. Remember, if you need to, I'm going to write it out for us. So it's going to be x to the second minus 2. So 2 minus 2 is 0. And what's x to the 0 power?
0.
No. You can always ask Dylan again. I think he knows the answer.
Wesley, Dylan, Ron, Sydney, anybody.
Remember the 0 exponent rule. Any number, I don't care what it is. Think about any number. That means anything except 0. So x to the 0 equals 1.
Okay.
All right. Now the last one. Y to the third divided by y to the first. So that's going to be y to the 3 minus 1, which is y to the what?
Repeat that.
Y to the third divided by y to the first. Now what that means, because we need to use the quotient rule. So it's going to be y to the 3 minus 1 power. So what's 3 minus 1?
2.
So it's to be y to the second. So the last move I would do here, just to clean it up, I would write 4xy plus 3y minus y to the second. In other words, I would just multiply by 1. All right? You got to know your rules. You got to know them. There's only 6. All right?
That's 12.
All right? Let's do one more like this. So find the quotient to 10d to the second minus 5d minus 2 all over 5d. All right, Leah. For this problem, what would be your first step?
You guys hear me?
Yeah, I can hear you.
Okay, sorry. My thing hasn't been working lately.
So
Did you do the 5D minus 5D?
nope. That wouldn't be my first step here. What would be the first thing I do?
You break it up. So you do the
Break it up. That's all I needed to hear. Perfect. Break it up. So we have 10d to the second over 5d minus 5d over 5d minus 2 over 5d. So remember, if your bottom or denominator is a monomial, one term, break it up. Now, let's simplify each one of these. Megan H, 10 divided by 5.
2.
D to the second divided by D to the first.
D.
Perfect. Put a minus sign. Next. Where's Hallie? 5 over 5.
1.
D over D.
1.
Perfect. Minus. Austin. 2 over 5. Can that be reduced?
No.
What about that letter D? Is there another D that I can reduce it with?
Nope.
So what happens to the very last term then?
Would that be like a remainder?
It's not a remainder. It just stays the same.
Stays the same.
Nothing you can do with it. So I would clean this up by multiplying 1 times 1. And actually, Austin, now that I think about it, because I wasn't really thinking, I would consider that a remainder. I would. Which leads us into our next topic. As the kids say, welcome to the gulag. Dylan, did the kids say that?
All the time.
Dylan, can you explain what that means? Welcome to the gulag.
Like COD?
Yeah.
Oh, it's when you die, you get like a second chance.
Here's our second chance of redemption. All right. Now, what makes this problem different from all the previous ones?
There's a binomial in the denominator.
Excellent, Wesley. Very good eyes. There's a binomial in the denominator. In other words, I can rewrite this problem if I wanted to like this. But the fact remains, there is a binomial in the denominator. Now, there are many techniques on how to do this, but I'm going to teach you the easiest one. And ironically, you already know the answer to this problem. How do we divide these two? We got to go old school. Long division. We got to go back to long division days. So what I'm going to do is I'm going to move the screen over to the left because I want us to review how to do long division. So this is what you would say. This is the problem. 5 divides into 141. All right? 5 divides into 141. Then you would start right here with the number 1. And you would say, can 5 go into 1? It's a yes or a no question. So I say no. Everybody else is saying no. So then what we need to do is expand our number. So now we ask the question, can 5 go into 14? The question is, or the answer is yes. How many times? I would say 2. So I put a 2 above the 4. And then I would write a 10. Now, where did I get the 10 from? 2 times 5 is 10. And what you're doing is subtracting here. Now, here's what's really happening, okay? Here's what's really happening. And maybe you've never even made this connection. When you say 5 goes into 14, what you're really telling me is this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. All right. You have 14 X's. And when you say 5 goes into 14, what you're doing is you're grouping these in groups of 5. So 1, 2, 3, 4, 5. So there's one group. 1, 2, 3, 4, 5. There's another group. And those 4 I cannot group together. That's what the remainder here is. But since we have a large number, 141, we have to drop down the 1. And now the entire process repeats. 5 goes into 41. I'm going to say 8 times. 8 times 5 is 40. With a 1. Now, we are big people now. We are transitioning into adulthood. We are not going to write 28 remainder 1 anymore. We are grown-ups. Does anybody know what the real answer to this is? Because it's not 28 remainder 1. What really is it?
28.2.
As a fraction, Wesley. Because my question to you is, where in the world did the 0.2 come from? And don't say your calculator. Because you're right. But as a student of mathematics, I would say, well, where's that 0.2 come from? I don't see a decimal anywhere in here.
Because 1 over 5 is the same as 20 over 100.
Perfect. So the real answer, everyone, is 28 1/5. Now, if you were to use a calculator, it would say 28.2, and that's because 1/5 as a decimal is 0.2. Does that make sense? Do we remember doing stuff like this? Okay. I always like doing this example, and then I always bridge it with like a building problem. Like if we were trying to build maybe a new bathroom on our house, and Leah's the boss, and Leah goes, "Flo, did you measure that wall?" And I went, "Oh, I did, Leah. It's 28 remainder 1." The next thing I would expect out of Leah's mouth would be, "What in the world are you talking about? Remainder 1." Like, it doesn't make sense. But if I said 28 1/5, then we know, oh, okay, I know that measurement. So what we're going to do is we're going to take this same lesson right here, and we're going to apply it to this problem right here. Now, remember, 141 over 5, or 141 divided by 5, the way you set that up, and these are names, maybe you didn't remember them, but that is called the numerator, or the dividend. The 5 is called the denominator, or the divisor. And then the number that you get up top is called the quotient. So what we're going to do is we're going to set up our problem with the divisor outside and our dividend inside. Now, off to the right, I'm going to give you the technique. These steps are the same steps every single time you do this problem, and they're basically like really simple questions. Give me 1 second, because I want to make sure that when I write this out, it makes complete sense. So I'm being careful about what I'm saying here, because I don't want any ambiguity. I don't want any confusion here. So give me a second. So how do I want to say this? How about I do this? All right. So step 1, you're going to take the first term in the dividend. Megan H., what is my first term in the dividend?
Y squared.
And I'm going to divide that by the first term in my divisor. Megan H., what is the first term in my divisor?
Y.
And when I divide those two things together, what do I get?
Y.
Perfect. Oops. All right. So that, whatever that happens to be, you will write in the quotient. Now, that is y to the first. Does everybody agree with that? So I'm going to put it directly above the y to the first term in my dividend. So there's step one. Are we all on the same page so far? All right, here's step two. Step two, we're going to take the quotient times the divisor. So underneath, I'm going to write y times y plus 3. And that's going to equal y to the second plus 3y. Does that make sense, everyone? And I always put this in parentheses. Okay? Now, this new thing that I have, this quantity y to the second plus 3y, I'm going to write directly underneath with a minus sign out front. Okay? Now, step three. Step three, all I have to do is subtract. Now, I want everybody just to watch the screen real quick. Okay? Because here's what I'm subtracting. I'm subtracting y squared minus y squared. And I'm subtracting 10y minus 3y. In other words, and I'm gonna color code them real quick. I'm subtracting that. And I'm subtracting that. Does that make sense, everyone? So, let me get rid of these colors real quick now. So there I get 0, and here I get 7y. Now, you know you're doing this correct because this term right here, let me highlight it again. That should always go to 0. Always. That's how you know you're on the right path. 10 minus 3 is going to be 7y. So if you think about it, we just did the first step in long division. We did the whole first thing. So once you do that, you drop down your next term. Does that make sense? Now, the process repeats all over again. This 7y plus 21 is your new dividend. In other words, watch what I do. All eyeballs up on the screen. Here's what I'm going to do. I erase this. I erase all of this. And I erase all of this. So the first term of my dividend is now 7y over y. And that's going to equal positive 7. And that number goes in my quotient. Then I take 7 times y plus 3. And that's going to give me 7y plus 21. I put it in parentheses. Now I'm going to subtract 7y minus 7y and then 21 minus 21, which gives me 0. So there's no remainder for this problem. So I'll write a little statement, a little sentence. Y to the second plus 10y plus 21 divided by y plus 3 equals y plus 7. Like I said, given the two cases that we can run into, dividing by a monomial is very easy. Dividing by a binomial or a trinomial, very intense. It's tedious. You can easily make a mistake. So what you want to be able to do is kind of have a game plan going in. Does that make sense, everyone? Now, I don't think, if I take a step back, I didn't teach you anything new. You already know the process of long division. The problem or the difference here is I'm giving you different numbers. Before, you were just using values. You were using integers or whole numbers. Now you're using algebraic expressions. But the process of long division is still the same. Does that make sense, everyone? All right. So just give me a minute here. I want to look something up real fast. Because I want to believe that when I was teaching this before, I had like better directions. So you see like here I taught it last semester. I just want to see like step 1, divide the first terms of each polynomial. Then I wrote dividend over divisor. Then step 2, I said multiply quotient times divisor, and then subtract and drop next term. So no, I think my process is still the same in terms of wording like the steps. So I think we're good. I think we're okay. I just want to make sure my directions are clear. Right, Amy? I mean, don't you hate it when somebody tells you, like, or they ask you to do something, but the directions are not clear? And then they get mad at you? And you're like, well, you didn't say that. I got into an argument with my dad. I'm 41. I got into an argument with my dad like 2 weeks ago up at his house. Here's what he said. This is what he said, Amy. He goes, can you just take the broom and just brush off the deck? I said, yeah, I could do that, Dad. I love you, buddy. I'll do it for you. You're the man. So I grabbed the broom and I'm sweeping the deck off. Now, on the other side of the house is a very small deck with some steps that go up to it. Now, I didn't do that one because he pointed at the front deck and that was it. So then when he comes in, he goes, what's wrong with you? How come you didn't do the other deck? I'm like, because you didn't tell me to. He's like, well, you would think you would do both decks. I was like, Dad, you specifically said, do this deck, and that was it. And he goes, yeah, but a normal person would have done both decks. And I went, oh, I guess I'm not normal now. And then I said, Dad, you know, when I'm teaching, I can't just say, only do this. Like, I got to really explain everything. I can't read minds, and I can't read yours. Needless to say, we were both hungry, therefore we were both angry, and that's why the argument actually happened. It wasn't because I didn't do the other deck, it's because we were both hungry. My wife calls it hangry. Anybody else get hangry like me? Megan H, you get hangry? Leah, you get hangry? I firmly believe when you see two people on the side of the street fighting and they're arguing and they're swearing at each other, if you would just run over and just stick a hamburger in everyone's mouth, I really believe all that escalation would just drop dramatically. Because they'd be like, oh my God, it was a pretty good hamburger. And then you can go, okay, what was the problem? Because let's be honest. There's nothing in this world that you need to scream about to anybody. Just be nice. So let's do one more problem like this, and then it's Friday. We'll call it a day. All right? Leah, what do you think? Pretty good? All right. So let's try this one. Now, if you want, just write down the problem and then put the pencil down. All right? And just watch. We're going to do the quantity of 2x to the second minus 3x minus 20 divided by x minus 4, okay? So I'm going to set this up. My divisor goes outside. And if you want to, you can even put that in parentheses. And then my dividend goes inside. Okay? Step 1. First term dividend divided by first term divisor. And this is why we really had to know our quotient rule for this. So this is going to be 2x to the second divided by x. Got to zoom out here a little bit. And that's going to equal 2x. That number goes in the quotient. And since it's raised to the first power, the 2x to the first, I'm going to put it directly above the 3x. So now, step 2. So we're going to go ahead and multiply. So we have 2x times x minus 4. And that's going to yield 2x to the second minus 8x. Now, remember, I put that in parentheses, and I write it directly underneath. 2x to the second minus 8x in parentheses, and I put a subtraction symbol. Step 3 is to subtract. Now, we already know 2x to the second minus 2x to the second is 0. In other words, these first two terms that are stacked on top of each other, that's going to be 0. What I'm really concerned with is what is negative 3x minus negative 8x. Does everybody see that? Let me highlight it for us. Negative 3x minus negative 8x. That's what I'm really concerned with. Okay? So I'm going to go ahead and just get rid of those highlights because I know negative 3x minus negative 8x is really negative 3x plus 8x, which is 11x. No, I'm wrong. It is 5x. It's Friday. That's my excuse for making that mistake. So I write 5x directly underneath, okay? Now I drop down the minus 20. And the entire process repeats. So, now the beautiful part about this, I'm recording this lecture. So if I were you, I strongly recommend, if you haven't watched one yet, watch this one, okay? Because I'm going to erase all my work except for the steps. And I'm going to start all over again. My first term in my dividend is 5x over x. And that's going to equal positive 5. So I write plus 5. Okay? Now I'm going to multiply 5 times x minus 4. That's going to give me 5x minus 20. I put this in parentheses, and I'll rewrite it over on the left-hand side with a subtraction symbol out front. Now the beautiful part about this, 5x minus 5x is 0. And negative 20 minus a negative 20 is really negative 20 plus 20, which is also 0. So 2x to the second minus 3x minus 20 divided by x minus 4 is equal to 2x plus 5. All right. Are there any questions before we end class? All right. I'm telling you right now, this is tough. I'm telling you right now, for a test, you'll have 2, possibly 3 of these problems. Because I do not want you sitting there for 45 minutes doing one problem. All right? Also, the 2 examples that we've done, there was no remainder. There will be a remainder in the next examples that we do on Monday. In addition, I will give you the properties or the checks. Like, we got to make sure these things happen before we even do this problem. And it's not difficult. It's just, does it do this? Does it this? That's it. So I'm going to leave us here. All right? I want you to have a good week.